The next speaker will be talking about the implications of securing backbone infrastructure. This is a topic that we've known about a long time, but it's also a crucial topic as you see the attacks in the internet, as we used to say with the routing, going up and to the right. Ryan McDowell is from Sprint, and I understand you have a master's and a bachelor's in computer science, and you've been working for Sprint, helping them get this going for about 5 years.
Thank you. So just kind of a talk to let everybody know kind of what we're doing to help secure our backbone and kind of how that impacts people. So the first thing we did, we started deploying receive access lists on in Cisco World, or input filters on Juniper World, back in about 2002. We kind of did things like deny fragments, permit all our management type stuff like SSH, SNMP with secured with source and destination pairs, permit BGP, IGP, PIM, a subset of ICMP, permit UDP, high ports for traceroute, and then deny everything else and count it. So this is a graph showing kind of all the bad packets hitting the routers. So this is 1 hour intervals of all the packets that we drop. So you could kind of play name that worm, watch TCP back in September go through the roof. So this is the average number of packets hitting the router. This is the same thing, but this is the kind of the worst router in the network, same 1 hour interval. The graphs kind of line up very nicely. They're a little different, and the scale goes kind of through the roof. Just kind of how we put out receive ACLs. I found out that a lot less people run this than I actually thought. So it's really pretty simple to do, and it really helps you out. So basically, just build a basic access list, even if you start off as simple as permitting TCP, UDP, ICMP, GRE, whatever else you use, and then denying all other IP protocols. Replace all your statements with permit and throw it out there and look for matches where you don't expect it. We were surprised on how much other stuff is going to the router that we didn't even know about, and we blocked a lot of it. And just constantly improve it. Tighten down your IP addressing, add source destination pairs, cut your port ranges down. And we found you really need a good IP addressing strategy to make it scalable. We started off with our backbone space kind of numbered all over the place, and we had, if we wanted to actually do a good job, we'd have like 100-line ACL just to secure it all. So we did a lot of work to put all our loopbacks into uniform ranges and then filter on that. So the end result is it made our routers a whole lot harder to kill. There really helps with kind of the magic packet attacks, like the last Cisco SNMP problem where one packet crashes the router, and it's kind of fun just to block it and receive ACL and not worry about reloading every router in the network, because that's not fun. We've had very few operational implications of deploying this. The question we get the most is, your routers are broken because I can't ping your router with a fragmented packet. Got a couple complaints when we turned off NTP, but that was really about it. So it's pretty low risk to do. One thing we found is change control can be kind of difficult to do this. If you want to have a separate receive ACL on every router, it can be very hard to automate, and it's kind of scary to automate because if you break it, it takes your router out. But it works out pretty well. And the problem is you still have some open holes in it. You can't close off 179. You can't close off ICMP. There's still some UDP, IP options attacks. So there's still, it helps a lot, but it's not perfect. So what we said next is, well, most of the attacks that we saw were actually to our customers' routers. So we would help mitigate an attack, do something, and then the attacker would take a step back and take out the customer's router. So we said, well, do we really need those IP addresses routed? They don't really serve a purpose. So let's stop routing the more specifics to those /30s. So what we did is we null route our aggregate block, and we advertise it via eBGP to ISPA up there. So the best route to the /24 becomes null zero on all the edge routers. We don't redistribute connected routes into BGP or IBGP, and we run next top self. So that 192.0.2.4/30 is basically unreachable from the rest of the network. And if that customer actually needs his .6, we just stick in a static route to the /32. So what that does for us is, I apologize for this inconvenience. So from ISPA, you can't attack that customer's router anymore. From ISPB, you still can, so it's not perfect, but now the attackers not only have to compromise a ton of hosts, they have to compromise them in the right location to attack the right person. So it makes their job a lot harder. And the key is we don't break things like URPF, so things like MTU discovery or traceroute do not break. So we're still going to pass the RPF check because we're advertising the aggregate, we're just not carrying the more specific. So like I said, it doesn't add 100% security, but it makes the job a whole lot harder for the attacker, and in the cat and mouse game there is, it's one-upping things, right? So we found that about 25% of our customers actually use the directly connected interface on the router, so that's a pretty small number, or quarter. It did take us about over a year to turn all our routers over. It was just a very slow process, very communication intensive with all the customers. A lot of folks didn't quite understand what we were trying to do, so it just took a long time to answer all the emails and communicate it well. But the implications, so traceroute's not broken, but any packets to the router, you can't really count on those working anymore. So things like ping to the router, and everybody loves to ping the routers, and traceroute to the router is also impacted. So once we got that done, we kind of started thinking, well, what could we do next? And this thought came around, well, can we do the same thing in the core and protect the actual core routers? And Cisco has advertised passive only, and you can do it with ISIS export policies in Juniper. And what you can do is same thing. So we're basically going to don't redistribute connected into BGP or IGP, run ISIS passive only. So then what you achieve there is somebody up behind ISPA can't reach either of those two networks there. Somebody behind ISPB can still reach something that he's directly connected to, but nothing further into the network. And then customer C can only reach things that he's directly connected to and a little bit further in. So it kind of protects the core of the network from anybody attacking it. You only can attack the router you're directly connected to, or one router behind it. But the implications of that are a little more intense, because now no one can ping any of our routers or anything like that. So we're not quite sure whether we're actually going to go forward with that or not yet. But some other things, use RFC 1918 loopbacks for management. Start using all your SNMP, all your SSH, IBGP. Doing that can really help you with the receive ACLs, because now if it's private address space, the odds of somebody defaulting into your network and spoofing your management address is really, really low. So it makes it almost impossible to reach in the first place, and anything that kind of slips through the cracks you can pick up with the receive ACLs and block it. There's some new features with receive ACLs like control plane policing that are coming out, even help a little more. Applying BTSH or the GTSH to receive ACL will help. If you use RFC 1918 for your IBGP, you're pretty much secured with the fact that it's 1918 and you can block it in your receive ACLs, and that only kind of leaves eBGP as vulnerable. And if you use BTSH in your receive ACL, you could kind of stop that off the block there just by setting your TTL to like 254. And the way we're thinking about initially deploying that is you can, in your receive ACL, permit, say, because it's going to take a long time to convert to BTSH with everybody, so permit say, TTL of greater than 253 and then less than 5. So it's not perfect, but it'll get you there until you can convert everybody. Block IP options, it's another attack vector that can go through the router. We've been running no IP source route forever, and it's basically the same thing. You get a packet with options set, you ignore them and just forward it as if they weren't set. So what does all this mean? It's basically saying is don't plan on sending any packets destined to the router that you're not directly connected to. But this is kind of already happening with the MPLization of networks, because all you're really seeing is the first router in and the last router out. It's much more secure infrastructure. It's not perfect, but it's a lot better than where most of us are now. And most importantly, it can all be done without ingress filtering, which is very, very difficult. So there's a couple references, and any questions?
Thank you very much. I guess